Welcome to AI PHYSEC Today, the first and only podcast dedicated to uncovering how AI is transforming the physical security industry. I'm your host, Don Marone, and today we're going to cover a topic I'm sure many of you have wondered about at the intersection of AI and physical security, which we'll answer. Is it camera analytics, machine learning, or deep learning? And of course, we have a very special guest with us today that's going to answer this exact question. Meet Florian Matusek, Managing Director of AI Strategy at Genetec. Based in Vienna, Austria, Florian co-founded Kiwi Security in 2008, a company that specialized in video analytics and software by bridging security and privacy, which was later acquired by Genetec. Florian holds a master's degree in computer graphics and digital image processing technology from the Vienna University of Technology, as well as a PhD in information processing science from the University of Oulu in Finland for his work on privacy protection and video surveillance. Florian truly is an expert at the intersection of video surveillance and AI technology, and I couldn't be more excited to have him as a guest, and you're going to learn why. So let's dive in. All right, Florian, welcome. Welcome to the podcast.
Well, thanks for inviting me. It's great to be here.
So before we get into the content, where we're going to understand the differences between camera analytics, what is that? What is machine learning? What is deep learning? And how those things differentiate within the camera space? I'd love to just know, right? So as a director of AI strategy, how many people like you exist in the security industry? Because this is the first that I've seen. Maybe I've seen another one with Linnell, but I don't know if there's anyone else like you. Maybe you're a diamond in the rough or such a rare breed, but I hope there's many of you. Certainly for my sake.
It is a good question, and as far as I know, I'm a first. But I'm glad to meet my colleague at Linnell. Yeah, so this is something that the need arose for that when we saw all the revolution that came with LLMs, right? Before I was dealing with video analytics, the classical stuff, even video analytics with machine learning and deep learning. But with all the new developments, it was necessary to take a more strategic view on where do we go, how do we think about AI, how do we think it's supposed to be used, how do we do it properly and responsibly, and I'm sure we're gonna get into all of this. But we felt it necessary to have this long-term view that also goes across product lines, right? I mean, we have multiple product lines in the company. And that's something that's important across all of these. It's not specific to one product that you would otherwise have. Like previously, I was only responsible for the product line, and now it's really going across products. So we felt with this fundamental shift in the industry, it's just something necessary and useful, and that's how it came. And it might be that I'm the first one.
Awesome. And I did give obviously an intro to your bio in the first part of the video, but also, you're on the AI advisory board too. I saw that.
Right. Yeah.
Awesome.
Yeah.
And that's fairly new, I think.
It is fairly new. Yeah. It was launched probably not even a year ago, I guess.
Gotcha.
And I find it very useful because SIA is a great forum. SIA is a great organization where leaders from the AI space, from different manufacturers that otherwise wouldn't talk to each other because they're competitors, go together and think about where do we want to go as an industry. And we do think about things like how to do this responsibly. Can we maybe find common guidelines across the industry, how to do that, to comply to regulation, but we get ahead of regulation. So it's a great forum, the SIA advisory board.
Well, if you have a seat open, holler at your boy, because I think I'm the only podcast dedicated to
Will
this.
do.
So, let me know. If anything, I could be a cheerleader to recruit some new talent. All right, awesome. So let's get into it. So the first part I want to talk about is the evolution of security camera technology, right? So in our audience, we have anywhere from end users to security integrators to even manufacturers that are listening in, and wherever they're at in their career. Maybe they're long-term people that have been around for a long time, right? Or maybe they just got started. And so I think it's good to start with this way. So maybe from a historical perspective, how have security cameras transitioned from basic motion detection, you can explain what that is, to incorporating advanced analytics, machine learning, and deep learning? And for the audience, those are AI terms, which we will go into detail about. But again, how have the security cameras transitioned from that basic motion detection to incorporating advanced analytics, ML, and DL?
So a lot has happened, right? I started in video analytics 20 years ago by now. And even before I went into it, motion detection was around. So we can even go back to the 90s and then probably even to analog cameras, where we had some kind of motion detection, which essentially is a technology just to figure out, does something move or doesn't it move? Where you look at individual pixels, do they change over time? And for a long time, this has been a good technology just to figure out where should I look. But it also has huge disadvantages, right? So any kind of disturbance in the image, and it could even be encoding issues in your video stream, or it could be a waving tree, or it could be rain or whatever. All of this is motion. So you have lots of stuff to look at, and it's actually used video encoding like MPEG-4 or so work. So those have been right in the beginning. And when I started 20 years ago, it was probably just the first wave of video analytics. Back then, we saw companies like Optic Video. And I remember when we went to customers and we told them we do video analytics, what the customer was expecting was the Lamborghini of video analytics. What we were able to deliver and what the state of the art was a bicycle, which is useful, right? It's like a bicycle is useful. But it was so not there what the customers were expecting, what they were seeing in movies, at CSI, and back then there was still 24 on TV and whatnot. And so much happened back then, right? Since then, we had a bunch of waves. 20 years ago, 15 years ago was maybe the first wave. Then maybe you could call it the video analytics winter, where everybody was disappointed that it's not the Lamborghini, it's just a bicycle. Probably around 2012, 2013, 14 came another wave, because 2012 came the big research paper that introduced what we call deep learning, which essentially is a technology where you can detect and classify objects like persons or vehicles much more accurately than we could before. So suddenly we could do stuff that people were expecting before much better and much more accurately, and then improved and improved and improved until now we have all these LLMs, and basic technology behind it is called transformers that even make it even better. And nowadays when we go to customers and we talk to them, then customers are still expecting the Lamborghini, and what we can deliver to them is a Ford Focus. So we got so much better in developing, and we got so much more accurate and so on, but we're still not quite there yet. So there's still some way to go, but there is it's just no comparison to 20 years ago. We're so much further, and video analytics is so much more accurate than it used to be.
Nothing wrong with a Ford, by the way. Okay, but I'd rather have a Lamborghini any day.
Absolutely, you know? Absolutely my point. It's a decent car. It's great.
Ford, I'm either an F-150 or a Bronco, though. Definitely not Focus, but that's okay. All right. So when we talk about defining the technologies, right? So can you delineate the difference between traditional video analytics, machine learning, and deep learning within the context of security surveillance?
Sure. So they're kind of overlapping fields. When we talk about video analytics, what we actually mean, what is being used is called computer vision, which essentially means computers analyzing a camera image. And there are multiple techniques on how you could do that, right? And before deep learning was there, before even machine learning was feasible, what you would do is you would analyze each individual pixel, see if they change, what we called motion detection before, then see how many pixels are belong together, maybe belong to an object, and then trying to follow this object from frame to frame, which we call tracking, which doesn't work very well if you do it based on a single pixel. But this is just one technology that could be used for computer vision. Nowadays, we still use computer vision, but we have better tools to do it. And one of them is machine learning, which roughly you could say it's a subfield of AI, what we call AI. So AI is much more than just machine learning, but machine learning is the part of AI that everybody's talking about today. And a subfield of AI is called deep learning. This is what was created basically in 2012. Back then there was a research paper called AlexNet by people that today we call the godfathers of AI. So basically started this AI revolution in 2012. And that was deep learning. And the big difference is with machine learning, we try to teach a machine to do something. So it kind of has a similar concept as the human brain. You have neurons and called neural networks, where we try to train this network on, for example, detecting a car or detecting if something is moving or so. And in the classical machine learning, you do this by really defining what it should learn. So it's basically saying, okay, here's some training data, and now you're going to learn how a tire looks like, for example, or going to learn that a car has 4 tires. That's what we define features. So we tell the system what features it should look for. And the big revolution with deep learning was that they figured out that if you just multiply exponentially the amount of data you feed into this network, like suddenly it's not, let's say, 100 images, but now it's 1 million images, that the network can learn by itself how to best detect a car. So previously we had to tell it a car has 4 wheels, but now we just feed a bunch of images into the network and it figures it itself out what best describes a car. And it might figure out that the best way is to describe with 4 wheels, but it might find a better way. And machines are much better in defining this themselves. So that's why it's much more accurate. And it's really, deep learning is a subfield of machine learning. And everything we hear about today, when we talk about ChatGPT, LLMs, all this stuff is all part of this deep learning technology.
Yeah, absolutely. So to cross a chasm from machine learning to deep learning, was that in that realm, that period where the big data was like there's a huge hype. There's probably like a decade or so, it felt like big data theory was talked about. Data science really started to take off in a big way. Is that what we're talking about, right? So it's like, wait a minute, machine learning, we can do this, but if we apply a bunch of data, big data, we can cross the chasm into deep learning.
It's part of it. It's part of it. So yes, suddenly we figured out data is the new gold, because if we don't have enough data, it just doesn't work. We need this data. But it wasn't the only reason. I mean, data science is using many other techniques that are not deep learning. I think it just came in parallel because we figured out we are producing so much data. There's so much IoT data, internet data out there. And we need to find a way to figure it out. And we do this with statistical models and other things, and also deep learning. Kind of came in parallel, but definitely for deep learning probably couldn't happen if we wouldn't have had this big data discussion and revolution.
Reminds me of, I think you posted something on LinkedIn where it's like, I think it was Radcliffe that was walking some dogs, the guy from Harry Potter, and it was saying
Uh-huh.
like, AI, it's a bit of statistics basically, almost.
Yeah. Well, it is. It is.
Yeah.
It's
Yeah.
just statistics, but it's so super complicated that honestly it's hard to grasp for any human. It's still kind of a black box. So we still have a hard time figuring out what's actually happening inside.
Explainability, I think, is some of the terms that they use, right?
Right, yeah. So explainable AI is a big thing, because obviously, and that's important for our industry, right? So especially if you, in critical situations, you use AI, you kind of would like to know more how it reaches certain decisions. Because even if it reaches the right decision in 99% of the time, it would be good to know on when it fails and why it fails. So that's why there are many initiatives going on. How can we figure this out? Can we make it explainable? But it's not easy. Like we did some experiments, and we did it internally where we created an explainable AI that basically told us how it figures out that this is a car, like my example before. And it was surprising. For sometimes it really goes for the tires, but for
Hmm.
some models, it checks out the headlights, and it distinguishes the different types of cars based on the shape of the headlight. That's something that we wouldn't have figured out otherwise. So it's very useful,
Interesting.
but it's also very hard to explain.
Yeah. So let's talk about some driving factors here. So what key technological advancements have propelled the integration of AI into security camera systems?
So I think there's two tracks. It's the software and hardware. On the software side, for sure, like I said before, this deep learning revolution, being more accurate, created a driving force and also pull from the market to try to get it into the cameras or to try to get it into the system somehow. Because suddenly we figured out that it has a much broader applicability than it did before. So I think there was some kind of market pressure to try to make it work, which also led to looking more on the hardware side, because if you don't have the hardware to do it, you cannot create the systems. And it's always going a bit back and forth. If you look at all the video analytics startups that came and are still coming, they focus first on server-based analytics because that's where the performance is. where first you get the really powerful stuff on the server side, which also means it's not super scalable or it's difficult to scale. Until the edge, the cameras are catching up. And then we are creating the hardware on the edge that is really optimized for AI. And then you can more and more put the applications on the edge. This is what we are seeing today, where most of the cameras have some kind of object detection, person detection. And not only that, I mean, they even know man, woman, color of the shirt, color of the pants, and something that was unthinkable just a few years ago. So both is influencing each other, software and hardware. And on both sides, actually, we need developments to push this further.
In the AI space, well, the AI space, no stranger to surprising people for what wasn't capable a couple of years ago.
Absolutely, absolutely. The security space always surprised everyone how long it takes to pick it up.
But see,
So
we're here to change that, right?
we're here to change that. Absolutely. Yeah.
We're here to change the tone, man. All right. So let's go on to practical applications and benefits. So let's start with real world implementation. So could you share examples of where AI enhanced security cameras have significantly improved surveillance outcomes?
Yeah. So, I mean, there are many examples, but it's sometimes from the outside, it's kind of hard to weed through them and find out what's actually being deployed, what's actually being used. I would say that perimeter protection is something that's being deployed quite a lot. So basically detecting a person at a perimeter climbing over a wall. It's still a hard problem to do, but still I see a lot of deployments using thermal cameras where we can get very accurate. And we also see a lot of deployments where you not only detect this on the camera, but you use it also for situational awareness, where you can project the detections on a map and you see how they're moving, which also allows you to combine it with other different technologies. And I think this is an important point where video analytics is still not 100% perfect. And for, I don't know, for a nuclear plant, it's probably not accurate enough. But what you can do is you can combine it with other kinds of sensors. So you might have thermal-based video analytics detection that you combine with a radar or microwave. And this way you get into a very resilient and accurate system. And this is what we see a lot. So perimeter protection for sure is something that is being used and deployed. What we also see a lot is anything around people counting, statistics. These kind of things are very interesting. Of course, we saw a huge uptick during COVID where you had restrictions, how many people are allowed to go into a shop. So there were lots of installations to count how many people are going in and out, maybe automatically triggering a red or a green light. And these installations just stuck around and we just took the light off and now we use it for statistics. And also there we are quite okay in terms of, we as an industry, in terms of accuracy. So people counting. And not only that, more and more we see on a wide scale deployments around occupancy. So it's not only like shops where you go in and out, but it's transportation, it's railway stations where you want to figure out how many people are waiting on the platform, front or waiting the back, and then trigger automations based on that. So if people are waiting in the front, you might want to trigger an automatic announcement to please go to the back to improve your operations. And even in addition, if you know how many people are in your train, in your wagons, you can already tell people where they should go in and out. And this is something that's increasingly happening with integration of different sensors. So in the train, it might be weight sensors inside of the car, and on the platform it might be video analytics. Yeah, and then there are some smaller applications where I know you talked about tampering detection, camera health. This is something that's definitely also being used in practice. Yeah, and where it's going and where it's increasingly being important is around everything that's forensic search. So I see kind of a trend where live alarming, it's not going away, but it's not so, I would say, hot anymore. People are still deploying it and using it, but more and more people are interested in how can I use video analytics to search through my data better. Because in the end, we're just recording and so on, and usually we don't know in advance what we want to search for. So it's kind of hard to create rules. So more and more people are asking for forensic search and asking to search through the data based on the properties that the cameras are creating anyway. So to make basically the data that's out there already useful. And that seems to be quite a trend at the moment where we're going, and it's actually being deployed quite a lot.
So do you see a lot of application where there's a collection of sensors that create statistics or analytics or information that operators can act on or use in some way.
I would say it's getting there. It's still something where we as an industry, I think we need better tools to do this and combine different kinds of sensor data. But we do see the first deployments doing that. And it's actually the same way goes for forensic search. So if you search through the data, you shouldn't care where the data comes from, right? The camera is just another sensor, but access control is a sensor, IoT is a sensor. And in the end, the operator just cares to close their case, right? We manufacturers coming from the technology space, we always think so much in terms of features and technology and how things work. But in the end, the user actually doesn't care, or you shouldn't care. Shouldn't care how it
They
works. It
think
just
about
should work right.
outcomes.
Yeah,
Yeah.
yeah.
They're
Outcomes
like,
are so super
don't
important.
show me the engine. Just take me where I need to go. I don't care. I always joke around. It's like the customers don't want to know the details of your flux capacitor. They just want to. They just want the outcome. And so I love it because I've seen manufacturers present sometimes, and it's very data sheet esque, and it could tend to get into that, and especially in highly technical things such as
Yeah,
this.
and
So
this is what like disturbs me a bit about AI. It's such a hype where the hype focuses so much on technology, right? You're absolutely right. Outcomes is really the way to go.
So let's move on just a little bit. So let's talk really quick about user experiences. So how has the integration of AI and security cameras transformed the end user experience, particularly in terms of monitoring and response, or any other way you'd like to respond to that?
Yeah, sure. Well, an obvious way is the kind of events that the user is getting, and this hasn't changed so much, honestly, in recent years. Yes, as I said, it got more accurate, but this is still something like we as an industry are struggling with because every time we introduce new technology that maybe is not like 100% perfect, it also means that we're actually creating more data, not less data. So this is why a good tip for end users is always to be aware that when you employ technology like video analytics, it might create more data than less. So it's very important to define your problem before you employ it, and just don't do it for the sake of it because you might make your operations um, less efficient than more efficient. But definitely, this has changed the reality of the operator. Like you have to deal now more with events and alarms, and maybe less with live monitoring. Something that, as an industry, we have been talking about. I feel like 15 years. Like black screen monitoring. You don't watch videos live anymore. That's over. You just look at the map. You just look at alarms. And it still hasn't happened completely yet, but we're definitely going in this direction. So yes, it's more about situational awareness, having an overview, looking at stuff where things are happening right now and not where they're not happening. And I think this has been a big shift for operators, which also means for supervisors that they have to think more about how they train their people. If they have high fluctuations, how to make sure the new operators get up to speed as systems become more and more complex.
Yeah. So before we move on to some other portions of the topics of the podcast, I'd love to interject with a question that I'm wondering, and I think the audience is probably wondering too, how they came here for. And when someone looks at this stuff, and there could be there could be two perspectives. When they say, okay, is this analytics, is it machine learning, is it deep learning, like what is this using? An end user, I think, probably doesn't, they won't necessarily pay attention to the differences, because I think we agree that they're pay attention to the outcome, right? They're saying, oh, it uses AI, but does whatever is inside this thing get me to what I need to go, right? So that's like the translation. But I do wonder though, as industry people, when we're talking about these things, like how does one know, or what are the characteristics, right? It kind of gets back to the earlier questions that we talked about. But how does one know, is this analytics, is this machine learning, or is this deep learning? Is there something that tips that off, in order to, like, something the camera can do that the other ones can't, that clearly tips that off to put it into that category?
So the big difference between the classical approach and machine learning slash deep learning is that deep learning classifies objects. Like it knows that this is a person and this is a vehicle, and this is not a tree. but that was previously not possible. Previously, just looked at motion, and the only thing it could figure out is, okay, this motion is maybe kind of this size and maybe moves this fast, so it might be a vehicle or a person. But all these traditional systems, they actually cannot tell you. So if it can't tell you it's a person or a vehicle, then it's not using deep learning. It's using the classical approach. And the difference between machine learning and deep learning, I think, is less important because as we move to new kind of chipsets or so, there's hardly any pure machine learning systems out there anymore. I feel like it was a short time frame where we had this. And there it's a little bit more difficult to tell because essentially deep learning is just more accurate than machine learning. But the big difference really is the classification between the old approach and the new approach.
So you mentioned if it can identify people in cars, then that's an indication that it's AI. Is that what I heard?
Yeah, yeah. But
What if,
again,
yeah,
again, it shouldn't be important, right? It should be about
right.
the accuracy, but yes, absolutely.
Yeah. So what if though reinforcement learning is not included? Like basically it's only as good as it gets based on when they first use it. So there's no mechanism for that user to say, okay, well, it picked up a car, but it was really a bicycle or something to give it negative reinforcement to not do that
So
again. So if it doesn't have that ability, is that still AI?
it is. And honestly, I don't know of any system where it actually learns in the field and it works.
Mm.
There
Oh,
have
okay.
been
Yeah,
a bunch of approaches, companies is just focusing on this, on continuous learning. And I haven't seen a single one where customers were really happy with it because it's super difficult. It's kind of easy to drift away and learn something bad. So all the major AIs, yeah, systems you have out there, they all have pre-trained models. And if you can give feedback, what happens in the background is that they upload this particular image to the R&D teams, and the R&D teams in the next round of training the model include it to make sure it gets more accurate, but it's not trained on the field for this specific customer.
do you have any insights or perspectives around how people or how manufacturers, whether or not they are building their own models, or is there some sort of hidden directory somewhere that people are white labeling? I know that both exist, but I didn't know if there's like a common theme that exists in the marketplace that you've seen. Like maybe there's few people that are actually building their own things, or there's others that are white labeling or taking a model that's already existed.
So of course, my competitors are not telling me how they're doing it,
Yeah,
but my guess is that so nowadays almost no one trains a model from scratch. There's always like kind of a base model, and then what you do is it's called transfer learning, where you take the base model and adapt it with your own data. So, for example, just learning how I don't know the structure of the world works or a person looks like or so. Those are all ready-made models, and I'm pretty sure that's the same for everybody. And I'm also pretty sure that most of them, so even people who say they only train their own model, down, if you look at the depth of the source code, I'm sure there's some kind of base model there, an
sure. Yeah.
image net or whatever. And then they train on their own data. I'm pretty sure that's the case for most of the manufacturers. So they do use their own data. And data in this space is not easy to come by, especially data that you are allowed to use. And I do think that not all manufacturers are looking at that if you're allowed to use it or not. So there's a bunch of stuff in the research space that's not for commercial use. We look like very deeply into that because in the AI space in general, this is not figured out yet what's legally possible or not. So we make sure we don't use any data that where there's any ambiguity. But I'm not sure everybody's doing that. So it might be that people are using public data sets or so on to train their models. And similarly, ready-made models, but I'm pretty sure everybody adapts their models somehow because you always want to improve it a bit and try to make it better if you're serious about AI.
Yeah, so actually that this is a great segue into the next piece where we talk about technical challenges and considerations. So as far as data requirements go, and I think I probably will likely have a follow-up to this question, depending on how you answer, but what types and volumes of data are essential to effectively train ML and DL models for security applications? So I already mentioned that it's so much that people will likely not train. It's enough where people will likely not create it from scratch and they'll use some kind of foundational work that's already been done. And, even to get this data, because I always thought it was interesting when businesses, they don't just have cameras sticking on their walls. And then like, who could afford to have cameras on their own real estate? And then that runs for like, who knows however period of time in order to gather own data that they own, that they don't have to buy or isn't necessarily what they need to serve their customers. And so maybe just on that. So types and volumes of data that are essential for this. Maybe we can
Yeah.
expand on that topic a little bit more.
So if you would include any kind of base model or so, then it definitely goes into the millions, tens of millions of images. But again, this is not something any single manufacturer can just do. So there are some base models. And then if you readapt it to your specific application, it really depends on what the application is and how it has to adapt to different kinds of environments. So for example, with person detection, you need more because people just look differently in different parts of the world. And the environment is different. There's heat, there's rain, there's snow. So there need to use much more, especially if you want to avoid any kind of biases or so. I mean, you want your model to work as well in India as it does in the US. So there, probably it goes in the hundred thousands of data that you want to deploy. But they're easy models as well. So let's say if you want to detect if the camera has been turned, right, you probably don't need a lot of data for this. So even if you have 1,000 images, it's probably enough. It really depends on the application.
So I want to ask you this. Thank you for that. I want to ask you a follow up to this, and I had a similar question to Daniel that was with earlier season of the podcast with Argus. Is this concept of not concept, but the reality of synthetic data and its ability to scale data, create data, generate data, right? To fill in the gap of certain things, right? And so to my knowledge, synthetic data is created using other Gen AI models. Maybe it's using something different that you're familiar with. But what's your take on leveraging synthetic data in order to enhance the abilities of these camera AI models? Like, given that
Yeah.
they have 100 images or something, but I can use synthetic data to replicate that to 1,000,000. And what's your thoughts on that?
So there are different types of synthetic data.
Okay.
On a basic level, that's something like we as manufacturers or so always did. It's called augmentation. So for example, if you take an image of an object, what you would always do is you would turn it, twist it, flip it to create more data, different kinds of environments. So that's maybe a basic type of synthetic data. And then what came up a few years ago, it was kind of a trend to use synthetic data in our space, which basically was creating a 3D environment. Lots of manufacturers did this, built their own tools using the Unreal engine from 3D games. And then what you can do is you can use Gen AI to enhance the texture of the people so they look more real. So this is something that's happening. Another tool is NVIDIA Omniverse that's specialized in this. And even
Exactly
actually,
what you're talking about.
if you look at the keynote at CES from Jensen, he actually is touching synthetic data. And what he's also saying, I find it very interesting, that real world data is not going away. And this is something that I think everybody found out 2-3 years ago, where synthetic data really came up and was such a hype that everybody was thinking, oh, great, now I can throw away my other data. I don't need it anymore. And everybody found out the same. It's not true. Well, synthetic data is great and it's necessary to close the gaps, as you said, but it cannot replace real data. So as an estimation, I would say maybe 10% of your data set could be synthetic. So you don't lose any kind of accuracy. But going beyond that, it's not doing so great, to be honest. And it might get better as models and 3D models get better, but today it's not, you cannot rely on it.
Yeah. It's interesting because I wonder, as the models improve, would we be able to rely on it more and change that 10% to a greater percent? Like, I don't know if quantum has to find its way in the mix or something, but I do wonder if that's going to change. Because I know what you're talking about though with NVIDIA Omniverse, because they just released Cosmos as their world
Yeah,
model that will
yeah.
basically, yeah, that will take their robot lab, let's say Isaac Sem, and be able to change the texture and so forth to understand 3D objects, because that's what, LLM certainly, right? But pretty much all foundation models, image generation, video generation has missed is a worldly perspective, and that's what's needed for robots, or at least they believe for general robots and everything else. And so it makes sense for cameras too, because cameras live in the physical world. And I think you're hitting on, I think what Jensen had released, especially if people that are in the physical security industry, and probably even more so people that are in the AI community and the physical security industry, like that's a big deal, you know. But I do wonder though, to your point, 10% is not a big impact. You know, it can save some money, but I do wonder if that will ever adjust. Do you think it will change from 10% to a higher, more meaningful percentage? And what would it take for that to happen in your mind?
I think it will, and it will reduce the moat for new players getting into space as well. So it will be much faster for you to train a model than before, where nowadays basically only the big manufacturers really can afford having big data sets. But I think it will always be that to reach a certain accuracy, so maybe the last 20% or something, you need real data. Because what I'm like intuitively a bit afraid of is that the same might happen with video data that happens with LLMs and the internet, where we found out that every time they train again and they train a new model, more and more content that they're using because it's on the internet is AI generated.
Oh yeah.
They're eating their own stuff, and it turns out that that means they get worse and worse because it's kind of like a closed system where you always need fresh input from the outside to get better. And I feel like something similar might happen in the video space as well, where you use a world model, which is great, but to get up to a certain point, you need some kind of input from reality as well. Otherwise, yeah, it just won't work in the real world.
Gotcha. Yeah, that thing was crazy. I think they fed like 20 million videos in order to make it some pretty substantial stuff. And then did you also check out, this is a sidebar for the audience, but did you also check out the NVIDIA's digits, their tiny supercomputer for like 3 grand?
That's amazing.
That seems like
That's
that's
amazing.
the next Genetech little remote AI box to me.
Well, I cannot comment on that, of course,
Yeah.
but absolutely no. This box is amazing, and it can do so much more than what previously was really a supercomputer for $3,000. Nothing.
I just bought their Jetson developer kit. It was like 250 bucks. It was the one he released like into last year. So I should have it
The
in like
super,
Q1, Q2.
yeah,
It's a little supercomputer.
yeah,
Yeah. All
it's
right.
pretty powerful.
Enough nerd sidebar for me. I am going to, or good sidebar, right? Let's talk a little bit about the ethical and privacy implications. We're physical security people. I joke about it all the time, but I get it, right? A little pessimistic, but a little realistic at the same time. And we have to be, we protect companies, our customers. And so these conversations come up, and I think it's naturally to talk about it here. And so, in regards to that, we'll start with privacy concerns. So, what are the primary privacy issues associated with AI driven surveillance, and how can they be mitigated?
So probably the number one you should mention is really the data sets, where we talked about this before. You need tons of data to do AI, but it also means that there is kind of a danger that you use data that you're not supposed to use. And especially with surveillance, it's a tricky case because the people who own the recorded data are not the people whose privacy is being breached, right? So if you have a street camera and somebody's walking by, you cannot just ask this person if it's okay to use their data because like we don't know who they are. So essentially, and that's the case for all data sets, essentially all data sets use information from people who could not directly consent to it, which is okay from a legal perspective and everything, and it's fine. But in the end, it means it is still like for the individual that's being reported, it might be a privacy issue. And connected to that, you have several legislations. Of course, I'm here in Europe. We have the GDPR, but you have the CCPA in California, and you have state laws. Where we have here in Europe the thing that's called the right to be forgotten, where everyone who is recorded somewhere has the right to go to the person who's recorded and say, "Hey, I want my data to be deleted." And it also means that it should be deleted from a data set that's being trained, right? Uh, so that's definitely a challenge that you have to navigate in addition to all the legal perspective, right? If we don't want to use training data that's being recorded in a Chinese prison camp for some whatever reason, so that's where we have to be very important on a manufacturer's basis. And then comes also the legal perspective to it, where we have currently there are huge legal cases. Probably the biggest one is the one of Getty Images against Stability AI, where Getty found out that Stability trained on their public available data because at one point Stability or Stable Diffusion outputs a generated image that has the watermark of Getty Images. So it's a pretty good indication that they do that. And Getty is suing Stability Diffusion, the manufacturer of Stable Diffusion, for $3 trillion, like a super crazy amount. Like
Wow.
it's like a made up number,
Yeah.
and it's still going on. So we're still trying to figure out if that's okay from a data perspective or not. And nobody really knows. So that's definitely a threat. So what can you do about it? So the important thing is internally to have strict guidelines and data controls. There is a principle called data minimalization. So you only use as much data as you need to achieve an outcome. So what you don't want is you don't want to record tons of data sets and tons of data that you don't need and store it. That's one thing. Then you also want to or need to control who has access to the data. So in terms of a manufacturer, you want to make sure that only the developers who need the data have access to the data and nobody else has this information. You also want to implement retention policies that your data is being deleted after a certain point. It's of course difficult with models, but it's also something you need to look at. And in the end, the most important thing is to be aware and to have policies in place to deal with it and make sure you're not just blind and use whatever you can get your hands on, but really do this responsibly.
And this must be especially tough when you run a global company, right? Like Europe with GDPR, and the U.S. is certainly trying, but they're not as progressive in that topic, right? And so, you know, it's one thing to be concerned, but then to also have to align with laws that could go down to US, like in the state region, is pretty crazy. Like how does a company, let's talk manufacturers for a second because you're on the side. Like, if someone's building these things, like how do they begin to accommodate something like that's so nuanced like that?
Yeah. So, well, obviously you have to be careful. And for things like, well, some things are more touchy than others. So facial recognition, for example, is very touchy, which is one of the reasons why we don't do it. And it did happen to one of our friendly market friends that they had to turn off certain features in certain states in the US, right? And you want to avoid that because it's really difficult to be a global company where you have to turn off features by region. So yeah, in the end, it's always a balance. You can try to stay away from more touchy things. And also, if you try to comply to the most restrictive regulations, for example, in Europe, also with the AI Act, you kind of like also ensure that probably all the other regions are fine. And this, I would say, is probably rather the approach we take. So we try to make sure we comply to the most strict regulations, and this way we can also kind of have a good feeling that it works in most of the regions.
Yeah, I was in San Francisco at an AI conference in 2024, and that was when the California Act was being presented. Obviously, it's a big problem, right? In Silicon Valley, basically all the AI companies are there making their stuff outside of like IBM or Microsoft. There was, and it wasn't approved. I guess California had spoken on that, but when I was there, the topic was between a senator or the conversation topic was between a senator and also a professor, I think at Stanford. And so they talked about this where on the development side, on the engineering side and the science side, a lot of researchers were they were for it, but against the idea because it could stagnate growth and that it's too early to do that. We don't know what it can be yet. It's also something that could make a big difference on where countries stand in the next economic world that we're going into. And then you have the really the government, right, stepping in saying, well, we need to do something about this because they have the interests of the people. And I think that's great, right? I think both have their own reasons to be right, and obviously as a European, you have the EU AI Act and GDPR, that data privacy is very, very important. But I do wonder though, like how when is too much regulation too much, right? To get to the point where does stagnate growth and it does put countries behind in this. And this is obviously a bigger topic than on cameras, right? So we can stick to the
Yeah.
idea of camera technology progression. This is something we probably would have over coffee at IC West, but not here.
Yeah. I think we
But I
can
do
talk
wonder
for
when we think
hours.
about, yes, but I think about technology progression in the camera space, right? Where we protect people, property, and profits, and we want to deliver the most. I think it's a lot easier because it's like at the end of the day, we're in the security space, and I don't think many customers want to take a concession on their data. So maybe the topic's not so complicated if we get down to the point of the business we do, just given the fact that it's we are in the security space, so it's almost expected that data privacy is the first thing we think about.
Yeah. So, I mean, how much regulation is too much regulation? It's really a hard question. Yes, Europe is being criticized quite a bit for regulating so much. And I've been involved in the AI Act like 3 years before it was published. I was working on the draft for it. I provided feedback,
Oh, wow.
and it was very bad in the beginning. Like in the beginning, it was focusing on the technology, and I'm kind of glad they pivoted more towards the application because, like, they wanted to say face recognition is not allowed, but it does make sense because you need it for border control. But yeah, I mean, you wanted mass surveillance. So yeah, it's kind of hard to say how much is too much. I do think that I'm not a huge fan of regulation, even though I understand why it's there, but it's just so slow compared to the technology progression. So I think there's much more onus or pressure on the manufacturers to step in and do the right thing. And it's also our approach. So what we introduced for our teams, we introduced pretty sophisticated responsible AI guidelines that are saying for each new project, you have to make sure like that the data privacy is right. We have lots of guidelines. You have to make sure we want to be explainable. We want to be accurate. We want to reduce bias. We want to make sure the human is in the loop. All these kinds of things. And what we do internally goes way beyond regulations because what we believe is as a manufacturer, we want to do the morally right thing, and complying to regulations is a side product of this. And so far, this works well, and we as manufacturers can be much quicker than regulations to adapt to it. So yes, I mean, it's fine if they do regulations, but I don't really think it solves the problem. It's more important to have responsible manufacturers that do the right thing and try to push this forward, which also means that it puts a bit of responsibility to the end users because they need to pick manufacturers to do that, which is kind of hard for end users to figure out. But one of the questions to ask as an end user is like, do you have responsible AI guidelines or something similar to at least know, does this company take this seriously?
Yeah. Yeah, it does present a lot of different challenges. And one of the things I've always wondered is, will manufacturer IT white papers change a lot, right? Where they have to talk about these things and be very, yeah, like you said, explainable, but to the point that it's saying, it's touching on these topics. And I do wonder sometimes, and you're in the right space with the board, on whether or not there will be new sort of industry certifications around this topic of what's passed the muster test of what's private and safe to use. But that's for another episode. So let's change gears here and talk about future directions and innovations. So emerging trends. So what upcoming advancements in AI do you foresee further transforming security camera technology?
Yeah, so obviously the big hype in the last 2 years is generative AI. To the end user, what they saw is of course ChatGPT and large language models. But below that is really the generative AI revolution. Actually, it's more than generative, which is called generative. It's transformers, which essentially make things much more accurate than they were before. And we will see this technology enter the security space more and more. And it's funny, in 2024, we saw a bunch of manufacturers, including us, starting to implement generative AI features into their products. However, it's been very early. Almost everyone who did that in 2024 did it basically as a prototype or as a demo. And if you look into it, then most of the time these kind of licenses are not activated and so on. We did it on our end. We implemented natural language search, where you really have a text box, and just like with ChatGPT, you can type in, "I want to see a person in a red shirt yesterday afternoon." at camera X, which enables a very natural way of interacting with the system, which again goes back to my point of training operators. So this is an effort to reduce complexity. We added so much complexity in the past, and now with LLMs, we have the ability, or natural language search, the ability to take the complexity back again and make it quite easy for manufacturers or for operators to do that. And we did that, and that's actually a feature that's in production that works. But we will see in the industry much more in 2025. We will see a lot of experimentation, a lot of demos, a lot of trade show features. I think as the whole industry is trying to figure out where does it fit and where does it actually make sense.
Yeah.
Like,
Have you?
does it?
Yeah.
Yeah.
Yeah. I was just going to say, have you? I know you've probably seen OpenAI's AGI, how there's steps to hitting that, right? So, do you think our industry is going to follow those same steps? And so, for the audience, AGI stands for Artificial General Intelligence, which is basically was, now that's changed into something else, but was the finish line for OpenAI, which was supposed to be equivalent of human intelligence, but that's arguable on so many levels. But the bottom line is they published this 5-stage piece in order to hit that, right? And so right now, I think they've already at stage 2, according to them, right? They kind of set these standards. I haven't seen that the AI space has set any standards or defined or come into a common agreement what AGI is. But knowing that you know that, Florian, like, how do you think the industry is going to go in that same route? So what you're saying is we're at the chatbot place, right? Are we going to now, I mean, incorporating a reasoning model just seems reasonable, no pun intended, especially if you're just taking in, downloading something from Hugging Face and fine tuning it or whatever and using RAG and all that other stuff, and then you've got agents, and then you've got, I think, research agents, and then you've got really a multi-agent organization where AI is doing the work for an organization. So that's like the 5 steps. Do you think we're going to go in that same direction, or do you see it changing somewhere, and maybe even give some predictions on when, right? So maybe
So
for
yeah,
us, is 2025 the year of experimental chatbots? We can go from there.
yeah. So actually, I think you're right. Yeah, we will see a lot of experimental chatbots. And if you compare it to OpenAI, it means that it comes like 3 years after ChatGPT. And I think this is a trend we see in the security space in general. Multiple reasons. We're a conservative industry, and it has its good reasons because we have to make sure it actually works. It's B2B, and so on. So that's why I think there's a natural delay, and we will see this with the same steps as well. And there's another reason that, especially if we talk about cameras, that video is so much more complicated than the text or other things, which is another reason why it will take longer, especially since I think the main challenge for video analytics, if we go back to that today, is really scalability, because it's so hard to scale that. A few years ago, 1,000 camera system was a big system for us. Nowadays, it's not a big system anymore. It's just like, it's common to have 1,000 cameras, and analyzing all these cameras takes so much resources and so much hardware that it's so expensive that in a lot of times it's not feasible. So it's not
Network
so much the
list goes on.
yeah, absolutely. So it's not so much being able to do it, but it's really doing it at scale and at cost. And this is why it will take longer, but eventually I think we'll get to a similar space. I think we will, of course, we'll see agentic AI agents doing different tasks in the security system, but I don't think it will replace the human, and I certainly don't hope so. I think, as in other spaces, the role of the operator will change. Probably we have to upskill them. They will be more strategic. They will have to guide the system. They will have to take the decisions. And that's one of our things in our responsible AI guidelines, that whenever there's an important decision to be made, we always make sure that the human is in the loop. So we provide the human all the information, but the human makes the judgment if something is good or bad. Our AI will never tell anybody if something's good or bad. It's really up to the human to decide. And I really hope that it's going in this direction, that we will automate more. We will have what we call the intelligent automation, but we will never replace the human completely. But then again, like, we don't know where AI is going. It's happening. Everything is happening so fast. So it will be interesting to see the progress this year and the year after to have a better idea on where we as an industry will go.
And you said something there I thought was interesting. So when you said AI would make a good or bad decision, is that because it's really a prediction. So it's never as good. It's never 100%, meaning we'll maintain human in the loop, for example, to make the 100% decision. As you know, I can fire or sue a human, but I don't want to admit that my AI did the wrong thing as a leader. And so I don't know what it is. Is that it? Because the technology just does not make 100%. Or, but what's interesting though, I think humans are just prediction models by themselves. It's just that, you know, like when we say something is something, right? That is like we say this is fact. You know, we know the world is round. That's like an objective statement, right? And so but we're accurate at 100%. Are we at like 99.99998%, something like that? You know, is there some degree to which it could be flat? And I'm not a flat
So
earther,
yeah,
by the way.
yeah. So I saw an interesting talk about self-driving cars where they asked, so how accurate does it have to be in order to put it on the road? Like, is it as accurate as a human? And they said, well, it's for a long time is it's accurate as a human. We only want to have it on the road. We only trust the car if it's like 1,000 times as accurate as a human. So in order to trust the machine, it has to be so much more accurate. I think this is one of the reasons. Of course, machines can be as good or even better than humans, but in order for us to trust it, it has to be much a magnitude better than a human. But then the other thing that you're mentioning, accountability, I think is a big thing as well. It's still not decided who is accountable if an AI system does a wrong decision. And I think it's also one of the reasons why we haven't seen so many automatic AI systems in warfare, because it's a really bad thing to like shoot something just based on an AI decision. And that, at least for now, we see this as very important that we have humans in the loop. But maybe it's also progress for us as a society, as we will see the next decades, and we are living with AI, that more and more we trust these systems, and maybe this might change. But today we feel like it's still very important to have a human who knows all the context of the whole environment of policies and their experience to make a decision. I mean, just imagine that if these things that we had during the Cuban Missile Crisis, where the Soviets wanted to send nuclear missile, and they only didn't because a guy just refused to do it, the AI system wouldn't have refused to do it. Humans are still sometimes better in making decisions.
I love it. So let's go ahead and end on that topic. Florian, thank you so much for being here. Hope you enjoyed the podcast. Looking
Absolutely.
forward to seeing you, man, at the shows. And hey, let's get more of you out there, right? But there can only be the first, and that's you.
Right. I love being the first. Thanks for the invite. It was really amazing and it was super fun. Thank you.
Hey, drop.